and that questions will be answered in a Q&A segment. The recording and certificate of this webinar will be sent out in 2 days' time. And our topic for today is about the precision ground testing, which will be presented by our very own Sumedi from Megger, Indonesia. So without any further ado, let me give you to Sumedi. Sumedi, bro.
Thank you, Michael, for your introduction. Yeah, good afternoon, good evening for everyone that joined in this webinar. Thank you for joining us on this webinar. So today I will try to present about the precision ground testing. So this webinar will be related to the grounding testing method. Yeah, this is the content that we try to explain on today's webinar. So I will not talk again about the basic theory of the grounding resistance and also like soil resistivity, because we already have many webinar regarding to the topic. But today I will more talk about the and focus on the grounding testing method. So at the end, or the main goal of this webinar today, I hope we will understand clearly about each method in order to get the precision grounding testing. Because there are many methods or alternative method testing to define the ground resistance. I will explain about the fall of potential method, simplified fall of potential method, 61.8 or 62% rule method, slope methods, and dead earth or two-pole method, start delta method, for potential method, and the last one is climb-on method. So after that, I will show you the chart to see the comparison between all methods. So we can selecting the earth system or electrode test method that give you more precise measurement. And the last topic, I will try to introduce again about our new product related to the grounding resistance test. We have the DAT23, and I will try to talk features and benefits as a precision grounding tester. The first method is triple or fall off potential. This is the full method. This is very common, and I believe everyone already, some of you may be already familiar with this method. This is the classic method for measuring resistance of a single grounding electrode or system of electrode to earth. Just overview. Actually, every grounding tester in the market, I believe they have the same methodology. Whereas the earth tester generates an AC signal, which is fit into the system under test, and then the instrument checks the status of the circuits for good connection, and also maybe if there is noise or no. If either they find any dust variables, maybe out of specification from the instrument tester, then we'll give information to the operator. But again, depending on the feature of the equipment. The instrument will automatically step through its measurement range, and the voltage generates the instrument to calculate and display the system resistance in range 0.001 ohm to 20 kilo ohm, depending on the instrument tester. So triple or fall of potential method is actually, it is part of the basic method. Actually, there are three methods. We call it basic method. One of three method is fall of potential or triple method, and the other one, maybe you know, the dead earth method, the 2 point. I will also explain that method, and the last climb-on method. So three methods are the basic method to measure the grounding resistance. Yeah, for fall of potential, in the full method, there are 3 steps if you want to do this method on the testing. The first is verification of P2 or potential probe by regular step long straight line between electrode under electrode under test, and C2 the current probe, and then you can put the potential probe every maybe the same distance, 10%, 20%, 30%, up to end of the distance up to the current probe, and then you can see the result on its measurement and plot graph of the resistance measurement to the paper maybe, and then resistance of system you can take when you see there is in the linear or in the flat area. So it is the 3-step standard to test grounding resistance with the full fall off potential method. Yeah, this is the example connection. You can see there are ground electrode under test. We give mark X, and this is the auxiliary potential probe in between electrode under test and the current probe at the end. So the P probe must be outside of the sphere of influence. So actually, in both electrodes, electrode under test and also auxiliary current probe, there are electrical field because we inject voltage and current will flow to the both electrodes. So on each electrode will provide the electrical field. So we need to ensure this probe or potential probe is far away from both influence or both interference. Then if you put the potential probe like this, you will get the true measurement. Okay. Now this is also the same picture that before, but here you can see the slope graph. This is the slope graph. You can put the potential probe from maybe 10%, 20%, 30%, and with the same distance range up to maybe 80 or 90% here. Then you can see the resistance value on each measurement. So when you see in the flat area, I mean maybe in here, so you can take that position as the true measurement. So the measurement on that position will be valid for your measurement. And from many cases, you can put this. Normally, it will around 62% to get the true measurement based on the many experience. So it is just for your information. Okay, next. And you need to avoid this condition. So in case if the potential rod is placed too close with the electrode under test, then the interference or electrical field will be happen, and then there will be overlap between both the electrodes. So on this condition, you will not get the true measurement or the correct measurement. If you get the inconsistent result, if you put here 10%, 20%, 40%, up to 80%, and then you get the inconsistent or result, means you are in the interference position. So you need to move the current probe far away from the original, from the beginning position, and you can try again with the same procedure. So it is the method of the fall of potential method. I believe this is very common using in the market, and this is the advantage information. I think the only one method that conform with the IEEE standard is the fall of potential methods. So it is the advantage, one of the advantage of this method, more reliable and conform and follow the international standard. And also can be used to test any size system, in the small system, medium, and also even the large system, still valid to get the true measurement with this method. And highly accurate, significant for low resistance in 1 up to 2 ohm ground value. So this is the method that so far on reliable and precise result, but also have some disadvantage, because extremely time consuming and labor intensive, and also so if you have limited space, limited area, I think you will have problem when you use this method, because sometimes we don't have enough place to put current probe far away from the electrode under test, and also the individual ground electrodes must be disconnected from the system. So you need to measure individual ground only. This is the typical probe spacing for the single electrode. Usually we can put the C probe 15 meters away from the electrode under test, and potential probe around 9.5 meters away. For the large system, it can be up to 60 meters. So imagine if you have the small area, I think you will have the problem, difficulty to follow this the method. Okay. Yeah, it is the first method, fall of potential, and the second method is simplified fall of potential. It is almost the same, but we try to reduce testing time. So on this method, actually similar to the fall of potential as described in the IEEE standard, IEEE 81, but you start with the P, I mean the potential probe midway from the center distance between electrode under test and current probe. You start from there, and then you take 2 more measurements, move to the left maybe 10 or 20%, and then move to the right the same distance, 10% or 20%. So you will get the 3 measurements, R1, R2, and R3. In example, this, if you see this slide, the first measurement, R1, you can put 50% between electrode under test and current probe. You get a measurement, R1, and then you move to the left side, maybe for 20% or 10%, then you get the R2. The same way, you move to the right side from the center position, 10% away from the center, you get measurement R3. So now you can the next step is you need to do this the calculation to make sure this method is still acceptable on your system. Okay, so you can calculate the average, or we got the RA, R1 plus R2 plus R3 divided 3 average value. In example, you get the RA, and then you also need to determine the maximum deviation between from the average by finding the greatest difference between individual reading and average. Individual reading here R1, because we want to use this as a actual measurement. So you see the deviation between R1 to the RA average, resistance average. If 1.2, if you see this slide, if 1.2 times this percentage is less than your desired test accuracy, and then RA can be used as the test result, the valid result. So you can use the RA value for your true measurement, as long as 1.2% of percent deviation less than your desired percentage. In example, to define 10% or 5%, it is depending on the customer. So how accurate your measurement? Maybe some company they put here 5%, other company they put the 10%. So this is, we need to define the limit value on this value. Okay. Yeah, the connection for testing same like fault of potential method, like this. Yeah, this method can give sufficient accuracy, but still will always give values on the low side. Yeah, because depending on the customer, if they put bigger standard here, and then the correct will be less. If they put lower, and then maybe they will get the good accurate measurement. Yeah, this is the advantage and disadvantage of this method actually. Yeah, the advantage of the simplified fault potential is much faster, because we just take 3 measurements compared to the full of fault potential. We need to take maybe more than 3, depending how long the system we put the current probe. But this advantage is less reliable. Yeah, and also as because depending the customer itself how much they put the percentage standard. Okay, continue to the next method is 61.8 rule method, or some people call it this 62, because they just make it easy to call 62 rule method. 62 rule method is just take one measurement in the 62% of the total distance between electrode under test and current probe. Yeah. And then they will use this measurement as a true result, true measurement. I will not explain why we got this value. Actually, there is a behind calculation how we put this why there is this method on the market to define the ground resistance value. But still, you can find this method actually. Yeah, this is one of the some method to measure the ground resistance with the fixed value 62% from the electrode, because most of the cases they can confirm there is no more interference between two electrode under test and the current probe when they put the potential probe in 62%. Okay, next method is a slope method. This is also I think this is quite good method to define the distance, the proper distance position of potential probe. Yeah, the further technique was involved and is described here. It is easy to use and has been shown to give satisfactory result. Both in theoretical and practical cases, and when the soil is non-homogeneous, it is called the slope method. Here. You can see the slope method, we just take a few measurements here. It involves taking tree reading. Yeah, we take a tree reading, 20% from the total distance to the current probe, 40% and 60%. So from just 3 measurements, you need to some calculation to define a proper, position on the potential probe. Yeah, as you know, I think from the previous webinar, the rule of thumb distance of the C, actually you need to put C probe is 3 up to 5 times from the system, grounding system. So if you have the grounding system maybe 2 meters square, means you need to put the C probe is far away around 6 up to 10 meters from your grounding system. But you need to know the center or the end of your grounding system. Yeah, it is the thumb of rule, a rule of thumb to put the current probe. Okay. Yeah, we just want to make sure we don't put our potential probe in the interference area. So we need to define the correct position on the potential probe. Yeah, this is the method, how we do this method actually. Yeah, to apply this technique, you need to follow this procedure. You choose the confidence road. E means the total distance from electrode under test to the C probe, and you can insert the current probe maybe 2 or 3 times the maximum dimension of the system that I informed you before. And then you insert the potential probe at distance equal to 20%, 40%, and 60%. It is the mandatory value 20, 40, 60 for this slope method. You cannot put maybe 25, 45. No. For this method, you need to follow this procedure: 20%, 40%, or 60%, and then you will get the 3 resistance: R1 for the 20%, R2 for 40%, and R3 for the 60%. So after you got 3 measurements, you need to calculate to find the slope coefficient, where is with this formula, the R3 minus R2, and then divide it R2 minus R1. So from this formula, you will get some value number, and then you can use that value to find the distance from the table. I will show you in the next slide. the first measurement, this is an example. You get the measurement on the 20% distance, this one, and then you get the R1. In example, you got maybe 9.3 ohm from your instrument test, from the measurement test. And then second test, you test again in the 40%. You get maybe 16 ohm with the same procedure, 3 rods. And the last test, you got R3, maybe in this example 19.2 ohm. So you use this formula to find the coefficient value from those measurements, and then you will get the 0.478 from this calculation. We got this value 0.47478, and then this value you can use to find the table. You can find the table from the instruction manual from the instrument tester. Usually they will give you this table. An example like this. From 0.478 means 0.47 from the coefficient, this one, and the third decimal to define this value. So 0.47 you find from this value, and then 8 you use the same row and find 8 value here, and then you will find this value 0.632. So this value you can use it for to put the potential probe. So means we got this value. If the distance from electrode under test to the current probe is B, means you need to put the potential probe in 0.632B. So the measurement on this position, we can use it for a true measurement. This is the actual measurement. Then we confirm if you put here, it will not affect to the interference from any electrode. This is the slope method. So you need to test 3 times measurement, and then you need to do some calculation to define the proper distance here. Okay, and the table that I said, the table of value for the coefficient of slope again actual piece probe is published in the instrument user guide. If Megger, usually Megger will give this table for every the ground tester equipment that using the pole method. Otherwise, if you buy the clamp on method, you will not get this instruction. Take calculated value of coefficient and look up ideal distance of the voltage spike of probe for measuring the electrode resistance. The advantage of this method is provide an approach for dealing with complex systems. So if you have the complex system, it's very good, and large system, very good to use this method. This advantage, yes, still because this method still not follow the IEEE standard. This is based on the experience from the scientific people. They try to do some research, and this method can be used for testing ground resistance. Yeah, and also requires more math because you need to do calculation and you need to see the table to define. But if you already familiar with this method, I think will be fast and efficient to testing your ground system. Okay, next, direct measurement. This is the tuple method. I think we measure coupling between two earth points of the ground electrode to earth. With the same philosophy, Ohm law, voltage divided current, you will get the resistance on this method. Yeah, the dead earth method or two-pole method is simplest way, I think, compared to other methods to make an earth resistance test, ground resistance test. With this method, uh, resistance of two electrodes in series is measured actually. Actually, this method measures two series resistance. If you put the here, you can see if you put if you connect to the pipe here means this method measures two series resistance, electrode under test, and also the resistance from this pipe. So there are three important limitations on this method actually. Yeah, in this case, we use the water pipe. Yeah, you need to consider the water pipe system must be extensive enough to have the negligible resistance. So we need to make sure it's very low resistance on the water pipe. And the second uh, consideration is, I think, the water pipe system must be metallic throughout without any insulating coupling or flange. So to make sure all current pass to this electrode. The last one is dirt electrode under test must be far enough away from the electrode under test. So I think it is the one of the problem using this method, because if you find the water pipe too close with the electrode under test, you cannot use it, because we confirm there will be interference position between the electrode under test and the water pipe here. So you need to consider just and make sure the position of the water pipe or maybe external rod must be far away from the electrode under test. Yeah. Yeah, this is the disadvantage of this method actually, because the measurement is series measurement, so it will give less accurate measurement on this method. And also you still must disconnect individual ground, same like other method. But usually, and we use this method on the last option, because if you compare the accurate percentage between other method, I think this method is quite a bad. But for the certain condition, you can use this as initial identification. Next, start delta method. On the start delta method, this is if you have the space problem. Yeah, if you have the space problem to measure the ground resistance on your system, I think this method can be used to measure the ground resistance. In the picture you can see here, actually we want to measure this ground E, and then you can do some measurement with different angle, 120-degree angle between them. So, and then you need to take sig measurement. On this method, you need to take sig measurement, and then you can see the value. And yeah, on this method, quite a lot math process to define your measurement is valid, or you need to retest your measurement. Yeah. Sorry. I think from this one, this is the ground under test E or R1. You need to do SIG measurement. R1 is you measure to the R disposition. R13, R14, and R12. And then you do measurement on the R2 to the R4 and continue to R2 and 3 and 3 and 4. With the two-pole method, you can measure those measurement with two-pole method. In example, if you want to measure the R13, R13 means this point, this point to this R3. So you can take measurement using the two-pole method, like this. Yeah, like this. And then you got the R13 and continue to the other measurement, R14, R12. So total is 6 measurement. After you got 6 measurement, you can calculate the R1 or the ground electrode being test value with this formula. R1 equal with the half R12 plus R13 minus R23. You got the value in this formula, and then you calculate again with the different formula. And so every resistance you need to calculate with the three-way formula. So and then you can compare the result. If you got the result is close each other, mean the measurement is valid. You can use that measurement as your reference. But if you got the difference between R1 from this formula and this formula, you need to do retest, and maybe you need to put this point, 3 point, this one, R2, R4, and R3, move far away a little bit to make sure and you got the same value from these three formula. So if all R1 calculation match, and then you satisfactory condition have existed. So if you didn't find this condition, and then you can find in where position make it this values not match, you can calculate from R2 with the same formula, from R3, and from R4. If some of this value not match, means you can define from this point, you need to move far away, maybe from the R3 or R4 or R2. So it is the star delta method. It's very useful for in the urban location where it's difficult to find the long or the large system to put the long current cable, current probe. I think you can use this method as alternative method. The advantage is provide an approach for dealing with the complex system where the slope method does not work. But this advantage is quite time consuming, especially because there are many calculation, many match formula. You need to calculate every single formula and less accurate compared to the fault of potential, of course, because the only fault of the potential method is more reliable and good accurate. And requires extensive math. Yeah, also this one of this advantage of this method. Next method is for potential method. This is another method based on the fault of potential, first introduced by Dr. G.F. Tech in 1964. And you need to take 6 different positions for potential probe in 4 formula. So you need to put to take measurement on the 20%, 40%, 50%, 60%, 70%, and the last one is 80%. So same as delta star, I think, sig measurement. You need to take a sig measurement. And from that measurement, you got R1, R2, R3, R4, and up to R6. And the four results for the R infinity should substantially agree, and the average of the result can be calculated. So again, you need to put the all measurement, sig measurements, to this formula. If the result from the equation in the right screen is invariant from the other result, it can be ignored, and the average calculated from the other three results. So if different, you need to ignore this method, I think, this measurement. The advantage of this method is with complex system where electrical center is difficult. So if you difficult to find the center of your grounding system, I think you can use this alternative method to define the better measurement. But still, this has have some disadvantage, like time consuming, requires a large distance for this distance of the current probe. Maybe can rank up to 2,000 feet or more, and requires extensive math. Yeah, again, mathematic issue, I think. The last method is clamp on. I think this is the last method that I will explain on this webinar, today webinar. Yeah, the clamp method actually using the Ohm law. If you open the jaw, the clamp, actually there are the two coil inside the clamp. One voltage coil, and the other one is the current coil. So the voltage coil generate the AC voltage, and then current flowing to the system. Sorry, and then we'll measure the induced current. If you know the voltage and you measure the current, and then of course with the Ohm law you can calculate the resistance value. This is very useful method, especially if you want to measure the system that's not possible to disconnect the ground system. With this method, you still can measure the resistance without disconnecting the ground electrode. Okay, and this is the greater number of parallel paths, the closer the measured value will be to the actual earth resistance. So this method will give you more accurate result if your system has many path system, parallel path in the circuit. You can compare if you have the 4 parallel path in the circuit. The actual electrode on this example 10 ohm, and you measure here the actual electrode 10 ohm, you measure around 12.5 ohm. But if you have more paths, in this example 12 maybe, yeah, 12, with the same value on its resistance, you will get the close to the actual electrode 10.83. So more paths will give you more accurate result on this method. But if you have only one path, of course the result will be not accurate, very less accurate. But you still can find your problem. I mean the resistance, the grounding problem. If you have the different value on each path, the example on this ground has 50 ohm, very poor electrode value. If you measure here, you will get maybe around 52.5. But if you measure on other parts, it will be same, 13.1. So at least you know which part has a problem, has a poor electrode with this method. If as long as you don't really need the accurate measurement, I think this method is very useful for you. Yeah. Consideration when using clamp ground tester, effective only in situation with multiple ground in parallel, such as pole ground, requires a good return path, so it cannot be used on isolated ground. And the last one is cannot be used if an alternate lower resistance return path exists not inform the soil. What does mean of this explanation? So as long as you put the clamp to the electrode under test that going directly to the soil, you will get the correct, the close to the actual measurement. But the problem if you put this clamp to the other electrode that not connect directly to the soil. An example here, maybe the loop, you want to measure here this ground, but actually this loop lower than other loop. So as the Ohm law philosophy, actually you just measure the resistance value of this bar, not the ground resistance value actually. Yes, you need to make sure the ground electrode must be connect directly to the soil. Yeah, it is the all method that I explained, and this is the chart to see what is the best application, advantage, and limitation. So from this table, you can verify which method that gives you precise grounding testing. As we know, fault of potential is the best one to do this measurement. Best application on a small electrode system, and also complex system if full resistance curve is plotted. And also with some advantage because conform to the IEEE standard, extremely reliable, and with the IRT with clamp, no requirement to disconnect. So still possible without disconnect the ground system as long as you use the IRT attached rod technique. I didn't explain this, but actually almost same as current clamp on, but here with this method still using the fault of potential, but we add one clamp to measure the current flowing to the electrode under test. The limitation you can see also on this uh, chart. And simplified fault of potential can be used on small and medium electrode system with some advantage and some limitation. And slope test, especially very good for the large system like in the substation. And that are so far not really recommended for two-pole method, but you can use this method together with the star delta actually, because star delta method using that odd method to measure each resistance on the SIG measurement. And star delta from ground system located in urban area where is a limited space, you can try to measure the star delta method. For potential in medium to large ground system can be used also. And the last one is clamp on if not possible to disconnect every ground system and not really concerned on the accurate measurement. I think the clamp on is or stackless method is the best one, quick and easy. Yeah, it is the method that I know, and we can share this, and then hopefully you can understand clearly what which method is give you precise grounding testing. And the last topic is we have the new the grounding tester DT23, where is can do some testing based on some method. Or I think all method. This equipment can do 4-pole, technique, 4-pole, 3-pole, triple testing with fault potential or depth measurement, dual clamp on methods with the dual clamp, and also can measure the current, leakage current, and continuity. This is very good instrument because complete method can be done through this unit. And also talking about the precise measurement, this is very good because this equipment has 1 milliohm resolution. So if you expect the ground system less than 1 ohm or less than 0.5 ohm, I think very good measurement because it has very low resolution, 1 milliohm with the accuracy 0.5%. And this equipment also has some feature like this, color display, give you benefit for graphical functionality. You can use in the daylight with the sun condition. Very clearly, you can see the display. You also can set the distance for resistivity calculation. I think I don't explain this recipe, but you can see on the previous webinar. And view spike check result. So this equipment can give you information if there is some connection is not connect properly, or maybe because there is some corrections, or you can see it on this indication. Checklist mean already looping, and if you see the cross, you need to check that route. Analog filter and also auto frequency selection. I think, as you know from the previous webinar, the frequency can be used to eliminate some noise in the field. So our instrument DT, this DT23, can select the proper frequency automatically. You don't need to choose how much frequency I need to set because this equipment can select automatically. So you can say smart equipment. And data logging up to 500 record, save up to 500 point. You can edit your name of individual record. You can download directly to the flash drive, and also compatible to use PowerDB. That it is the Megger general software, and autofill form. It automatically will fill the form that you can see on the PowerDB software. And graphical result trace, you can view live measurement over time, diagnose the problem by viewing trend, and start stop graph to capture a fall of potential curve. This is very good feature. I think you can see the graph directly on the unit. And other feature and benefit, weatherproof IP45 and 65 if unit close to the cover, and Cat4 300 volt protection, 4 hours battery life with fast recharge. This is very, especially if you do long testing on the field, very good instrument. Also has the continuity mode, stateless, and RT mode. And also we have the all new test lead on the reel. So this is the problem on the site. I think based on my experience also, after you finish test, you need to move to other position to make sure your measurement is true, is good. Sometimes you have a problem and takes longer time than the first testing. You need to repair the tangle cable that happen if you put the cable long cable. So with the real facility, you will avoid this condition on the field. We have the some length 2 meter up to 20 meter to 100 meter length. Yeah, I think I finished the presentation today. Now we can go to the quick Q&A session. Michael, I can
Yes,
send to
that
you.
is a wonderful presentation, Zoom. Thank you so much for that presentation. So guys, now if you have any questions, please type in the chat box and we will answer it for you. By the way, for those who are leaving, please don't forget to fill up the survey form, and that survey form, we need that to help us improve in the future webinars. Okay, so now let's move on to the question and answer portion. We have one question here, bro, and I guess
Yeah,
you
I
mentioned this
think,
one.
are there any standard distance among those spikes? If you see, I think I also already explained this term of row of time, yeah, about the distance between spike thing. Depend on the method also. To define the current spike, you can use the row of time 3 up to 5 time of the your grounding system. That my explanation before. If you have the system 2 meters square, means you need to put the current clamp 6 meters to 10 meters. But to put the potential probe depend on the method that you use. If you use the 62%, you can put the 60%. If you use the full of potential, you need to put many position. If you put the slope, you need to define first to put your potential probe. Yeah, I think it is my answer.
Yeah, they can also refer to our guide. We have a
Yeah, yeah,
getting
right.
down to earth. So you can
Correct.
download that one from the Megger website, and you will see also the table there, recommended distances for the current and potential probe. So yeah. Okay, so another question here, bro. I'm not sure if you can answer this one. If required grounding resistance value cannot be obtained, how we can do that?
If required grounding value cannot be obtained, 1 ohm. How we can do that? Yeah, I think
Maybe he's asking what to do to obtain the correct grounding resistance.
yeah, I think it is according to the design, I believe. Yeah. If you already measure but you didn't get low resistance value, I mean you didn't get the one less than 1 ohm, there are too many possibility. Maybe the design of the grounding itself, or maybe the instrument also, or maybe the method. So there are many uh, possibility. The reason why we cannot get the less than one ohm, especially if
Correct.
they said on the previous test they can get less than 1 ohm, but now suddenly they cannot get the less than 1 ohm. So I think they need to check the method, the instrument, and also maybe some people they try to put any the additional chemical chemical part to make sure the ground resistance is can reduce, yeah. But I don't remember the name of the chemical part, yeah. But depend,
Yeah,
it
that's
depend. Yeah.
correct. So that's why it is really, really important that you measured your soil resistivity first so that you will know where to put the ground electrode correctly.
Yeah, correct. You're right, Michael.
All right. So, hmm, in the three-pole slope method, the chart in slide 24 is from which standard?
Okay, the standard, I need to check, but I believe only fault of potential you can see on the standard. But for the slope method and other method, I believe it has on the maybe like
It's I
pub.
triple 81.
Oh, you have you seen?
Yeah, the standard for grounding testing is I triple E 81.
Yeah, the standard is
So
IEEE 81. But as
they
I
can
know,
they can
only
refer
for the
follow
fall of
potential.
potential.
Correct.
Yeah, but for slope, I think depend. Uh, I'm not sure. You can find it in the IEEE. As I know, it is the based on the reset. I mean I
Well,
will check.
anyway, this
Yeah,
technique, bro, is just an alternative. So if the slope of potential test or the follow potential test is not possible, then they can do this, or they can do the clamp on, or they can do the attach rod technique. or they can do the direct connection technique, like the water pipe. So
Yeah.
those are technique. So it depends on the application, sir. So if it's not possible, then you can do that to check. So you have many ways. For me, if I cannot do the follow potential, then I will try any other technique. So if I get good result for those other techniques, like not just one, but I will try also the clamp. I will try also the attached rod technique or the direct connection. So whichever is possible. So if I have three results that are good, then I can be confident that my grounding system is okay. And then also I can do the touch and step potential test just to make safe to be safe, to make sure
Yeah.
that I am safe. So I guess that's all the questions that we have, bro. So guys, if you have any other questions, you can send us email and we'll try it to answer via email too. So again, everyone, thank you so much for attending this webinar and hope to see you again on our future webinars. We have a lot until December, I guess. So please stay safe, everyone, and have a good day.